Bottoms up, bottoms up. Don't throw your heads up. Factoring can be easy if you use the bottoms up, bottoms up, bottoms up. Don't you give up. Before you do, consider the bottoms up. I know what it is. Hey, just having a little fun. Actually, you may think I'm singing the song that you're used to hearing on the radio, but I'm really not. I'm actually giving you an insight as to what's going to be our next method we're going to discuss. And we're going to determine how we use this bottoms-up method to factor trinomials of the form ax squared plus bx plus c equals 0. Let's go ahead and consider how this method, which is called the bottoms-up method, believe it or not, it is called the bottoms-up method. Let's see how this method is used to factor trinomials that are of this form. Basically, the method that we're going to use actually hinges on whenever we had the form where a, the coefficient of the squared or the leading term, was just positive 1, and we said, okay, if we had a polynomial that was like this, x squared plus 7x plus 10 equals 0, then we can factor this. We said that the factored form from this is just taking this power, split it, put one here, put one there, and then to get determine the terms that goes here is just a matter of finding two factors of 10 such that when you add the two factors you get 7. And you listed your factors 10, 1, and 10, 2, and 5. Oops, 2 and 5, if I were to add them, I get 7. So you say, okay, well, how do you place signs in the front of these two guys to get a positive 7? You say 2 must be plus, and a plus must be in the front of the 5, and then you put them in just like that. Basically, we're going to use that same concept of whenever we had the coefficient being 1, it was just a matter of focusing on this last term and finding two factors of that last term to put in here and here. Well, the bottoms-up method kind of hinges on that, and so before we can use the method, though, the idea is to basically try to force this trinomial to become a trinomial where the coefficient of the square term is 1. And basically the way the method works is this. First thing you want to do is you want to bring down this middle guy here, the middle coefficient, and its sign. So that's a plus 1x, or just plus x. The next thing we want to do is we want to establish a new constant term here and a new leading term here. And that's just the way the method works. The way you establish this new constant term is just a matter of multiplying this guy times that guy. So the 6 times the 12. 6 12s are 72. So that becomes, and I'm using the same sign. 72 goes here. So again, this is formed from multiplying the a value and the c value. A and c, and that's the original a value and the c value. And then right here, we're just going to force this leading term to just be a leading term where the coefficient is just 1. So in other words, we just drop the coefficient and bring down the variable to that power. So we want to, in a sense, as I said, we want to force this to be 1. Force a to equals 1. That's all it is. So once we do that, then we have, it's not an equivalent trinomial, but we have a new trinomial where the coefficient is 1, and we say, well, hey, we can factor this case. In this case, factoring this case is simply just a matter of finding two factors of this guy such that when you subtract them in this case, you get a positive 1. So what are factors of 72 such that when you subtract them, you get a positive 1? Let's see. Factors of 72. 1, 72. If you subtract them, you will not get 1. 2 and 36. What's that? 3 and 24. 4 and what? 18. If you subtract those, you will not get 1. That's what we're looking for. 5 does not go. How about 6? 6 and what gives you 72? 6 and 12? Nope. 7 doesn't go. What about 8? 8 and 9. Oh, look. If you subtract those, we get a 1. Now, we want to get a positive 1, but we know these will definitely work if we subtract them. So the idea now is to say, how do I get a positive 1 out of this kind of case here? What has to be the sign in the front of the 9? What has to be the sign in the front of the 8 to get a positive 1? Well, the 9 has to have a plus sign. The 8 has to have a negative sign. Because we know whenever we're subtracting implies it's something with opposite signs. the two values have opposite signs. So you have to just place the signs accordingly in front of the two values so that you get the results you want here. So once we have these two guys and the signs, we know x goes in these positions because of the first term being x squared. It's just a matter of splitting that power in half. One goes here, one goes there. And then we use these two factors we just found, minus 8 plus 9, and we put them in. So now this is the factored form for this particular trinomial. We want the factored form for this guy. But in order to get the factored form for this guy, it's a matter of going through the process of finding the factored form for this guy. And we saw how this guy was established. Now, here's what we want to do at this point. The next thing we want to do in the next step is we want to divide the two values we just placed in, the L values, the values in the last position, because we know with the FOIL acronym it's first, outer, inner, last. So the two values in the last position. Divide the L values with original coefficient. So we want to take those values there and we want to divide them by the original coefficient. The original coefficient was what, 6? So we put the 6 here, 6 here. And now, what we want to do now is we want to reduce. So the next step is we want to reduce the two fractions. Reduce. So we reduce the two fractions. Now this is going to be x minus, well, 2 is a factor in both of these guys. So we can say 2 goes into 8 4 times, 2 goes into 6 3 times. And here, 3 is a factor in both of those guys. 3 goes into 9 3 times, and 3 goes into 6 2 times. Now, here's why it's called the bottoms up method, is because the next step and the last step to determine the factored form for the original polynomial is just a matter of taking the bottoms and bringing them up. So you take the denominators of the fraction, or the bottoms, and bringing them up to the coefficient. So this becomes now 3x minus 4. And this becomes here 2x plus 3. So you just bring in the bottoms to each coefficient for each binomial. And now we know the factored form for the original polynomial. That's the bottoms up method. So go ahead and try it with another problem and see how you guys like the method. And tell me, please, tell me how you like the method. Comment. Leave comments and let me know. Alright? Thank you.